Welcome to our Algebra 2 unit run review. This is our guest in our Algebra 2 lesson today. This is Ruja. He's a super old cat, but he's a really good cat, and he's very good at algebra because he's listened to a lot of algebra lessons over the years. But we're going to see if we can get him to maybe move on through. There we go. Okay. So this video is for anybody who either is absent on our review day or just wants a little extra review, wants to preview what's on the study guide. Yeah, just going over the study guide problems again or for the first time, whatever you need. Okay, so we're going to just take a look at the study guide together. So this is exactly what's on your study guide. It says, first one, state the transformations of a function from its parent function. And I would really like to change my view. I don't know how I can do that. It is not letting me. Oh, view. Here we go. Hang on. Presenter view. Let's try that. Okay, that's a little bit better. Just on my screen, like where I could write was super tiny. So I try to get it a little bit bigger. Okay, so the first one says state the transformations of a function from its parent function. So for example, the parent function that we focused on in this particular unit was the absolute value of x. So you get f of x is equal to the absolute value of x. Now remember that you can, if you want to, you can use a y there. Like that's fine. Like try not to let the f of x throw you off. And then we have the function g, which is 0.5 times the absolute value of x plus 1 minus 2. And so essentially what we're going to do is look at each of the things that we have going on, which in this particular problem are 3 things, and we want to state what those 3 things are doing. So if you are multiplying the function by a number less than 1, that is a vertical compression. If it is a number greater than 1, it would be a vertical stretch. Think of it this way, like the number multiplying the x in a linear equation is the slope, and the bigger the slope, the steeper the line. So it's like taking your absolute value and making it steeper and steeper and steeper. If it's less than 1, or if it's a smaller number, it's going to make it less and less and less steep. That's literally what's happening here. So that is a vertical compression. If you are adding 1 on the inside, okay, adding 1 on the inside means that it is going to go left 1 unit, and you need to state the direction and how far it's going to go in that direction. And then subtracting a 2 outside the absolute value will make the graph go down 2. Now, this particular review problem covers certain things that you might see, but there are more things. So to prepare for this question, you want to go back into your notes, homework, the lesson video where we did the transformations, maybe the homework worksheet or the in-class notes, whatever you got, where we are describing the transformations. Your answer should look something like that, okay? So your answer should not be equations. It should not be intervals. You shouldn't be trying to solve anything. The directions, they state the transformation. So your answer should take that form. Question 2, or the second number on our study guide, is similar. State the transformations from one function to another where neither is the parent. So you can try to do this in your head, but on your test, I am providing a coordinate plane for scratch work. And it will say that you can use the coordinate plane for scratch work, but you're going to be graded on your answer. Now, the reason I'm putting that on there is because it helps us to see what's happening. So in this first one, we have a negative. That means that the absolute value function is flipped over, okay? The 2 means it is stretched. So we're going to flip it over and we're going to stretch it out. Then we have the minus 3 on the inside, which is going to send us right 1, 2, 3, and then the minus 5 on the outside, which means we're going to go down 1, 2, 3, 4, 5. So 3 to the right, 5 down, and so it's really it's going to be, the vertex is going to be there, and it's going to be flipped over and fairly skinny. This is just a sketch, okay? We're just doing this to get an idea of what's going on. Now, the new one has none of that going on out front, Okay, so this is going to be right side up, and it's not going to be stretched out. It's going to be back to normal. The -5 means that it's going to go to the right 5. So 1, 2, 3, 4, 5. And then +2 means it's going to go up 2. Okay, and it is going to be pointed upward and not as skinny as the first one. So the question is, to get from the green one to the blue one, what do we have to do? Okay, well, first of all, we have to flip it back over again. Okay, and I'm okay if you just say flip. With the absolute values, a horizontal flip or a flip over that y-axis is not that much. So it doesn't do that. Yeah, that was poorly phrased. You can't see it from the parent. Now you can see it if you like slide it and then flip it, but we haven't really looked at anything like that. So I'm okay if you just say flip. Then it went from being skinny to like not skinny, which means that we did a vertical compression again to get from one to the other. Okay, so we had to flip it over and we had to go from skinny to not as skinny. Then we made it go, we were here, right, at the right 3, and we end up right 5. So we had to go right 2, and then we were way down here at the -5, and we go up to the +2, which means we had to go up 7. Remember, you can get partial credit. So if you feel like, well, I could have done the left and the right up and down like that, I could have gotten, I could maybe get the flip, but I don't think I would have gotten the vertical compression. Don't sweat it, okay? You don't have to get a perfect score to be able to pass the test or do well on the test. So do your best. Use the tools that you have, and get the part right that you can get right, and try to just kind of keep track of where your confidence level is. Again, I will provide for you on your test a coordinate plane that you can use for the sketching, but this piece right here that I'm circling, that's what you're actually going to be graded on. Okay, so make sure that you don't just sketch it, that you answer the question that was asked. All right, next one up is graph a line by building a table. I do this because while I know a lot of you can graph a line by plotting the y-intercept and counting the slope, I'm not as confident that we always understand why that works or why that connects the equation to that particular graph. Now, I will, for your test, provide you with the x coordinates. Okay, so you're not going to have to pick the x coordinates. Now for this, I'm going to pick like -4, -2, 0, 2, and 4. And the reason I'm picking even numbers is because of the fraction. If I have to take 1/2 of something, I would like the 1/2 of it to be even, because then I can cut it in half. Otherwise I'll get a decimal. So I'm starting with the 4, and I'm starting with the 4 because I think it's the most intuitive. If I plug in x is 4, I would say 1/2 of 4 is 2, and 2 minus 3 is -1. So we're just going to fill that in. Trying the 2, half of 2 is 1, and 1 minus 3 is -2. 0 is the best number ever because 1/2 times 0 is 0, and 0 minus 3 would be -3. Now at this point, if you're observant, you're probably going to notice I think we have a pattern here, and you would be correct because it's a line. So this is a linear pattern. But you can keep going. Half of -2 is -1. And then -1 minus 3 is going to give you -4. And probably you can figure that the last one here is going to be -5. Half of -4 is -2, and -2 minus 3 is -5. You should notice on your table on the test that there is a pattern, okay, because it's a line. It's a very specific kind of pattern. And then go ahead and graph it. And so we need negative numbers here. So we've got -4, -5, -2, -4, 0, -3, 2, -2, and 4, -1. and then you connect them, and voila, there's your line. And you will be provided with a coordinate plane. You'll be provided with a table and some space to do your scratch work. Okay. You are allowed to use a calculator, but not your phone. And for this test, not a computer either. So there might be some like hand calculations that you need to do. You could also get this line by using the shortcut. So you plot the y-intercept, which is -3, and then count rise over run. So you would have a rise of 1 and a run of 2. And just notice what happens. If I start here and I go up 1 and over 2, it's going to give me that point. So there is a faster way to get those points than by using the table. But I have found that a lot of students do make mistakes when they're using that shortcut, and it's not worth it. So for this, you will need to use to build the table. Okay, so write the equation of a line given 2 points on it, and you have to use the strategies reviewed in class for this skill. Now, I'm actually going to have you do something before, and what I'm going to have you do is plot the points. 4, 5, 6, 7, okay, and answer some questions. So the point -2, 7 is going to be up there, and the point 2, -1 is going to be here, and your line should go through those. And what I'm going to ask you is, when you're looking at your line, is the slope of this line positive or negative? If it is tilting down, then the slope is negative. If it's tilting up from left to right, then the slope should be positive. I'm also going to ask you to estimate where you think the y-intercept is. Now, if you're doing a really, really fast graph like I did, mine is fast and it's also sloppy. Like I'm not even going through this point over here. But I have an idea of where my y-intercept should be. 1, 2, 3, 4, 5. So it looks like it's around 5. Okay. I mean, this is a bad graph, so I'm not going to be surprised if it's not 5. But what I do know is that my y-intercept is not negative, and I don't think it's probably going to be a 1 or a 2 either. Okay, so I'm guessing when I do the work for this, that my slope should be negative and my y-intercept should be around 5. And I want you to use that to check your work to see if the answer you're getting is a reasonable answer. That being said, the way that you're going to find that equation is you are going to use the formula for slope and plug in your points. So we're going to have 7 minus -1 over -2 minus 2. So that's going to be 7 plus 1 over -4, which will be 8 divided by -4 or -2. And I'm confident in that because I knew my slope was negative. Now, in a pinch, if you blank out on that, you're like, I don't remember the formula for this, I have to take a 0 on this problem. No, you don't. You don't have to take a 0. If you don't remember how to do that, come over here and count from this point to this point, and you'll be like, well, hopefully not surprised. If I count rise over run, I am going to go down 8 and right 4. Rise over run is going to give me the -2. If you don't remember the formula for slope, see if you can count it. Okay, get that number. You can get the -2 more than one way. So I mean, I want you to use the formula because not every problem is going to have numbers that you can just plot them and count them. But if it's a test problem, maybe you can, and at least that's going to allow you to move forward with the problem. It's going to buy you more partial credit. Now, to write the equation for the line, we need the slope and we need the y-intercept. I've got my slope, okay? So my slope is -2. What I'm going to do is borrow one of these points. I guess I'll go with that one. And I'm going to borrow the y is 7 and the x is -2. -2 times -2 is 4. And then I'm going to subtract 4 from both sides, and I'm going to get the y-intercept is equal to 3. Now, that seems a little bit low based off of my graph, but notice how my graph is like sitting up high there. Like my graph is really bad. So 3 is a little bit off from what it looks like on my graph, but it's not so far off that I'm convinced I did something wrong. If I'm a little shaky on that, I'll go double check it. Now, before you leave the problem, make sure you write the answer. The problem said write the equation of a line. So make sure that you have the equation of the line. In fact, I think I have a spot on your test that says my final equation is, to remind you that you're not just finding the slope and the y-intercept, you actually need to write the final equation. So the equation for the line that goes through those points is y equals negative 2x plus 3. Now, if I had gotten like a y-intercept of 1, if I had gotten a, whoops, there we go, a y-intercept of 1, if I had gotten a y-intercept of like 8 up here, then I would know that there was something wrong with my calculations. But 3 is close enough given how terrible my line is. And so you'll have a grid to do that. You'll probably have a better estimate than I have here. Question 5, be able to interpret the points in a linear application problem. So the example here is kind of from your class notes. It says the cost for a prom venue is C of X. Now C just means cost, X just means it's depending on the X, okay? If you want to, you can say Y equals 400 plus 15X. Or if you want it in slope-intercept form, you could say 15X plus 400, okay? Be flexible here. Using the word problem from class as context, what do the 400 and the 15 represent? So for this, you might need to go back to your notes and the problems we did, the Sunview Resort in the Lakeside Inn, or it was Sunside. Sunside is really hot. No, it wasn't Sunside. And so you kind of have to go back to that. But the idea was you paid a flat fee to rent the venue and then a fee per student. That per student, anything that's per, like if it's per minute, per hour, per mile, or for every hour or for every month, or like something that is expressed as a rate, something over something else, that's going to be your slope. And so in this particular problem, this number here would be the cost per student. And this here would be the flat fee. In your test problem, it's a longer problem. It's going to have more of the explanation, but your answer should be something that looks like this. The 15 represents cost per student, or the 400 represents the flat fee, or the 43 represents miles per gallon. Okay, you're going to give some kind of answer of that context. Okay. Number 6, solve an absolute value equation. So at the time I'm recording this is literally what we just did. Remember that the first step in solving an absolute value equation is to isolate the absolute value. So we want to get rid of that 1/2 and we want to get rid of that 2. Make sure that you are dealing with adding and subtracting before you're dealing with multiplying. And I showed you in class why you want to deal with that first. If you're going to get a fraction, you want the fraction to come out at the end of the problem. You don't want the fraction to come out in the middle, because then you have to do something with it. So start there. So what do we got here? We would undo adding by subtracting. So remember what drives our solutions, okay? You look at what is being done. This is adding. Therefore, if I don't want the adding there, the way I get rid of it is by subtracting whatever I added. If I add 2 and then I subtract 2, that's a 0. Just to keep it balanced, because it is an equation, you've got to make sure that you take that 2 from the other side as well. Now here we did this in like a really, really early lesson this year where we had the fractional coefficient, and we did this in class where we divided by 1/2. Okay. And I worked through it that way. If you do that, I mean, I can't take off, but that's pretty awful way to look at it. An easier way to interpret division, like if you want to divide by 1/2. Oh, and before I move on, how do we know we're dividing? Is because that is multiplication. It's 1/2 times. Therefore, if you want to undo it, you would undo it with the division. The problem with that is that like dividing by a fraction just looks awful. It's not really hard, but it looks hard. So this is the key thing you want to remember there, that division is just multiplication by the reciprocal. So 3 divided by 1/2 is literally 3 times 2/1. which is just 6. Okay. That's what division is. It's kind of like how like subtraction literally just means adding a negative. That's what it means. So you can pick whichever notation you want. We just don't use the multiplication division one as much. So instead of dividing by the 1/2, it's actually easier for most of us to think of that in terms of multiplying by 2. So I am going to erase that divide by 1/2 just because it's ugly. And why should we have ugliness? And we're going to replace that with a times 2. And so that gives us the absolute value of x minus 3 is equal to 6. Now, the absolute value literally means distance from 0 on the number line. That's literally what it means. So you want to say the distance from 0 of x minus 3 is 6. Well, what has a distance from 0 of 6? Well, it could be 6 or negative 6. So the x minus 3 could be either of those. And that's where we get our 2 equations from. And then we would just add 3. So x could be equal to 9. And give yourselves a beat with that whenever you're operating with the negatives. -6 plus 3 means you're going to move to the right on the number line. So that would be -3. Okay, and that's what you should show for work. You don't have to show things like this or your number line. That is for explanation purposes only. Your work would probably consist of something that looks like this. All right. Now I skipped over 7 and 8 because I'm not happy with those questions. I'm just, as a teacher, I'm legitimately not happy with them. I went and took your test and I'm like, I'm not super thrilled with that. So we're going to jump over those and we're going to cover the content from number 9 because I personally am undecided about what I want to do with questions 7 and 8. We will go over them. They're on the next slide, but we're going to go over this first in case you're in a rush. So given a graph of an absolute value function, be able to determine the following: vertex, axis of symmetry, end behavior, and where the graph is increasing, decreasing, positive, and negative. Now on your, I think there's multiple questions on this. I don't have a copy of the test with me. I'm at home. There might be some where you have to highlight, but the big question on this is actually a matching question. And so you're going to be given like the vocab. You're going to be given like the word vertex, axis of symmetry, end behavior, increasing, decreasing, positive, and negative. I actually don't think it's all of them. Okay, I think I picked some out. And then you are going to need to draw lines to match the answer with the vocab that goes with it. So we'll just, like, to review, we'll just go through this kind of, I guess, raw without the matching part. So the vertex is that point right there. So heaven help me if I can see that on my computer. I believe that is -5, -4. I think is where that one was. The axis of symmetry is the vertical line that goes straight down the middle, and vertical lines always take the form x equals, and since you know it goes through the vertex, the x coordinate of the vertex is -5. End behavior, you need to state the end and the direction that it points, and so in this case we would say the left points up and the right points up. Because we're looking at that. We're looking at the left side and the right side, and that they point up. Now, this is where it might get tricky. So if you look at these answers, there's really, I guess, the negative interval and the vertex could look the same for notation, but there's only one thing that is going to look like this, so you better match that up, right? And only one thing that's going to look like the axis of symmetry. Now, for your increasing is where the graph is going up from left to right, but you always name it with your x coordinates. And so you want to find the x coordinate where it starts going up and then the x coordinate where it stops going up. But here's the deal. It never stops going up. Okay, it's going to keep going forever and ever and ever. So it starts going up at the -5 and it keeps going up forever and ever and ever. Decreasing is going to be where it is heading down. Don't let that arrow throw you off. Like we're moving across the graph from left to right. So like from left to right, that's going down. Now it's going down from time eternity. Okay, like forever, way, way, way out there. So it starts going down way out here at -infinity and it stops when it gets to that -5. Again, remember that you're referencing that by the x coordinate. And then we have positive. Well, the positive interval is where it is above the x-axis. And you'll notice that there are two places where it is positive and they need to be stated in two separate expressions. So that, like the one right before it, starts at -infinity, but it stops, so help me, at -7. And then it's positive again over at -4, -3, and continues on to infinity. And then you'll see that little union symbol between them, just meaning it's both of these, like both of these work. It means union them together. So this and this together are the positive intervals. The negative interval would be where it is below the x-axis, and in this case it dips below at -7 and comes back up again at the -3. And so now I was saying earlier, this notation and this notation do look the same. This one is an ordered pair, this one is an interval. From -7 to -3. And if I'm seeing the numbers wrong on that, I'm really sorry. It's like really, really, really tiny on my computer, and I'm wearing my contacts, and my contacts are like not great. My glasses are actually a bit better. So that's that. And I think on your test, I think there's also some multiple choice questions. So there are some like questions that like, state the interval, and then you just got to pick it out of the options. All right, so the last part of this is 7 and 8, and these were the ones that when I was doing it out, I just wasn't super happy with the questions. So the 7 says, determine if given numbers are a solution to an inequality. The intent of this question is to assess whether you understand what it means for something to be a solution and know how to determine yes or no. And so the intent of that question is that you are going to go and plug in the options for x. So we would plug in like x is equal to 4, plug that in. 4 plus 1 is 5. The absolute value of 5 is 5. And 10 is less than or equal to 10. So technically, yes, that one works. And then you would do the same with the next one. You would go through, and 5 plus 1 is 6. Absolute value of 6 is 6, and we get 12 is less than or equal to 10, which is not true. So it's not the 5. All right, so just to be consistent, we'll like kind of keep going through, and there's space on your test to work that out. So we've got -3 plus 1, which is -2. Absolute value of -2 is 2, and 4 is less than or equal to 10. So that does work. And then the -8. And so -8 plus 1 is -7. Absolute value of -7 is 7. And you end up with like 14 is less than 10, which does not work. Okay. Now, the reason I was having questions about, am I really sure that I want you to do that, is because that is very tedious. And I kind of see where this might bog you down, either with an arithmetic error or misreading like greater than less than. There just are places where this could get maybe muddy and not assess what I want to determine. Because what I want to determine is whether or not you understand what a solution is. Okay. So that's what I'm going for. Now, the second part of this says, like, now that you've gone through and determined if numbers are solutions, it's a multiple choice question. It'll be an inequality notation, and you should choose the solution to the absolute value. So if I were to look at this on the number line, -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, so we're going all, oh, wait, and then we have 5. And then, so help me, 3, 2, 1, 0, and then -3. So what I know is that like -8 does not work. -3 does work. 4 does work, but 5 does not work. So what I'm looking for is I'm looking for an interval that contains the -3 and the 4, but not the -8 and the 5. So for instance, if I saw like an interval that said x is less than or equal to -6, I would not pick that because less than or equal to -6 would include the -8, and I know that doesn't work. So you're not going to eliminate that. And same with something like x is greater than 4. Well, no, I'm not going to pick that because it's like doesn't include the 5. And then like I might have one that has one of the numbers that works, but not the other one. So I might say, well, -3 is less than or equal to x is less than or equal to 6. And so that does include the -3 and the 4, but it's also going to bump out into the 5. And then there'll only be one that actually works, which in this case is less than or equal to the 4 is going to be like one end of it. -6. I think it's -6. I'm doing that in my head, which is super dangerous. But like only one of the answer choices is going to include the numbers that work and not include the others. So that's what those two questions are. But those questions are longer than I thought they would be. And again, like what I'm trying to assess is, do you understand what a solution is? And can you determine like yes or no? And then the second part is this multiple choice question that says, okay, now that you have these numbers, what do you want to do with them? So I haven't, at the time I'm recording this, decided what I want to do with those questions. If I want to take them off the test, if I want to make them bonus questions, if I want to just see how you guys do on it and then maybe just make them count, but they won't count a lot. I really don't know. So I wanted to review them, but I also kind of wanted to give you a heads up that I'm not totally convinced that I love how these questions are working out, but you know what I'm driving for on them. So that takes you through the entire study guide. For those of you that were wanting a review, I hope that helps and that you are able to organize your study time and you're not going to be surprised by any of the content that is on your test next week.